Okay, welcome students. In this discussion, we are going to take unit number 2, a design of experiments. Design of experiments. Okay. So, what is a design experiments? Design experiments na enna adha. So, it is just a test or series of tests. ஒரு டெஸ்ட் அல்லது சீரீஸ் ஆஃப் டெஸ்ட் எதை நம்ம என்ன சொல்கிறோம் அப்படின்னா டிசைன்ட் எக்ஸ்பெரிமெண்ட்ஸ் அப்படின்னு சொல்கிறோம். They play a very important role in engineering design and development. Engineering design layum development layum in the experiment of design takes very important role. Third point, it gives a better performance, higher reliability and lower overall costs. அதாவது இந்த designed experiments வந்து இந்த engineering design and developmentல better performance கொடுக்குது, high reliability and the overall cost is very less. அதாவது இந்த எக்ஸ்பெரிமெண்ட் பண்ணாமல் நம்ம ஒரு if we take some experiment, okay, it will make lot of costs and not a better performance, but in the design கொடுத்தோம் அப்படின்னா it gets better. Fourth point, through this experiment we learn systems and process work. அது எப்படி ஒர்க் ஆகுது, அந்த சிஸ்டம் வந்து எப்படி ஒர்க் ஆகுது அப்படிங்கிறத this particular experimental design helps us to get it. Okay, last one வந்து experiments are performed in all engineering and scientific disciplines. Scientific disciplinesலையும் engineeringலையும் இந்த experiment of design takes very important role. இங்கே ஒரு good example for that, ஒரு good example. அதாவது இங்கே பிரான்ச் 3 பிராண்ட் கொடுத்துருக்காங்க, இங்கே குரூப்ஸ் கொடுத்துருக்காங்க, ஏ குரூப், பி குரூப், சி குரூப், டி குரூப். ஸோ இந்த ஃபஸ்ட்டு பிராண்டில் ஏ குரூப் வந்து 0 அவுட்கம், ஃபஸ்ட்டு பிராண்டில் பி குரூப் அவுட்கம் இஸ் 4. இந்த ஃபஸ்ட்டு பிராண்ட் சி குரூப் gives 8. I mean the outcome of that is 8, or the connection of first brand which D is 15. Okay, this is a good designed experiments. ஏன்னா இது மாதிரி நம்ம டிசைன் பண்ணி ஒரு எக்ஸ்பெரிமெண்ட் பண்ணி அது அக்செப்டட் ஆச்சா அல்லது ரிஜெக்டட் ஆச்சா அப்படி நான் பார்க்கும்பொழுது the result would be very better. So this kind of experiments we call it as a designed experiments, not an ordinary experiment, design experiments. Okay, right, now look at that on the screen. We have what are the principle in the designed experiment. So in the design experiment we have 3 basic principles: randomization, replication, local control. Randomization, replication, local control. So இது ஒரு design. So this is the every element here undergoes randomization. Randomization means what? In Tamil, how can we say that? எதுக்குமே இம்பார்ட்டன்ஸ் கொடுக்காம டக் அப்படின்னு எடுக்கிறது, அதுதான் randomization. So this randomization put the objects in particular random orders. Now take for example here this B1. In B1 there are 16 elements are there. The 16 elements are taken at random without any predetermination. The elements are taken 16 here, 17 here, 20 here. All these are objects taken without any predetermination. Therefore the objects are put in random orders and the observations are independent. We observe something. I mean, correct, in the first day, first engine, 16 objects are there. It is a observation. So observations are independent. Okay, the B1, B2, B3 are treatment. Those are what we call burners, we say, treatment we say. So observations are independent. We observe what we observe. The objects are independent, and then we apply random treatment to the experimental units. So the units which are undergoes experiment is called experimental units, and the experimental unit we are giving a random treatment. That's what we have to understand. And then randomization makes the test valid. the test valid by randomization. So these are some of the important points in the randomization. Now comes replication. Replication means it is a repeated one. That's the meaning for replication. So independent executions are repeated many times. When we do that, the increase of accuracy of estimates the replication gives. So replication increases the accuracy of estimates. And then cost is too much by implication methods. Cost is too much. As the number of replication increases, the error is reduced. That is a use of replication. நிறைய டைம் நம்ம திருப்பி செய்யும் பொழுது எரர் கம்மியாகுது, காஸ்ட் வந்து ரொம்ப அதிகமாகுது. ஏன்னா we are doing again. And independent execution takes place each and every time. Accuracy இருக்கு இதில் replication பண்ணும் பொழுது. Now local control is the third basic principle in design of experiments. The third is about local control. இந்த local controlல மூணு இருக்குது: grouping, blocking and balancing. groupingனா என்ன அப்படின்னா homogeneous plots வந்து நம்ம ஒன்றா சேர்த்துறோம். we are combining homogeneous plots. That is called grouping. Blocking means assigning the same number of plots in different blocks. Okay, that is assigning the same number of treatment in different blocks. That's called what? Blocking. The last one is balancing. That is adjusting the grouping and blocking so as to balance configuration. Balance configuration வருவதற்காக அந்த குரூப்பையும் பிளாக்கையும் நாம் அசைன் பண்ணுறோம். That is called what? Blocking. Okay. What about the next question? What are the different types of experimental design? Okay, here these are what principles of design. Next one is about types of design. There are three types mainly. One is called CRD, completely randomized design. Okay, completely randomized design. That is what very important things that you have to understand. One example, so here what we do, one way analysis we do. Okay, so example is given here: mixture 1, mixture 2, mixture 3, and these will be any other dimensions on, take for example, first day, second day, third day, fourth day, fifth day. Mixture 1, take for example the first day any one measurement we can take. First day output 0.56, mixture 2 second day output 1.52. okay, so this is a good example for completely randomized design. Similarly, second example is this, where A, B, C, there are 3 treatments, 10 plots are there, and if we apply this treatment to this 10 plots, we are getting these are the yields, outcomes. So this is another example for CRD, completely randomized domain. In these cases we use one way analysis. How will you explain completely randomized design? So what is completely randomized design? That may be the question here. This is the simplest form of all the design. It is based on principle of randomization and replication. Which one? This completely randomized design எதை பேஸ் பண்ணியிருக்குது அப்படின்னா randomization, replication, அந்த ரெண்டு பிரின்சிபல் இங்கே அப்ளை ஆகுது. and this design is a very simple design. and third one, treatments are allocated at random to the experimental units. Treatments are allocated to the experimental units. This point already we have discussed. So these are what we call completely randomized domain. Now what are the merits or advantages of completely randomized design? Maximum use of the experimental units are done by this completely randomized design. அதாவது maximum number of experimental units is used here. Okay, it is very flexible, that is at any time it can be changed. We can change the design, the number of treatments can be used. The statistical analysis is very simple. The standard analysis we follow here, and next one, max number of degrees of freedom can be get by this method. So these are some of the merits of completely randomized domain. Now coming to the what are the demerits, that is the disadvantages of completely randomized design. The design suffers from the disadvantages, that is less informative. This is very less informative. Second one is restricted in any direction. Third one is whole variance among the experimental unit is residual variance. These are some of the disadvantages or demerits of completely randomized domain. Now CRD applications என்ன? The CRD is more useful in laboratory techniques and methodological studies. Methodological study laboratory techniques the CRD takes very important role. Second point, of course, biological experiments. In that particular case, CRD is very much used. Last in some greenhouse studies and etc., this RD is very much applied. Okay, so this is about CRD. Okay, so let me take some examples. The problem, how we can do that. So in these cases, we use one-way ANOVA. Okay, so one-way ANOVA, that's what we are using here. Before that, we'll see how many ANOVAs are there. ANOVA means analysis of variance. What is the meaning of that? To study the one group variations to other group variance. That is the variance of one group with respect to other group. That is what we called ANOVA. Okay, there are three types of ANOVA. One-way ANOVA, for what? To test the homogeneity between rows or columns only. அதாவது one-way ANOVAவில் நாம homogeneity between columns only or rows only or treatment only. Here or treatment only also we have to write here, or treatment only. So any one homogeneity, that is no significance, we are testing between rows or columns or treatment. That's called one-way ANOVA. A separate table is there. We will discuss that later. இப்போ ரெண்டு பக்கம் நம்ம அனலைஸ் பண்ணுறோம். அதாவது காலத்துக்குள்ளே ஹோமோஜினிட்டி இருக்குதா அல்லது ரோஸ்குள்ளே ஹோமோஜினிட்டி இருக்குதா. ஓகே, இந்த ரெண்டையுமே அட் அ டைமில் நம்ம கண்டுபிடிக்கிறோம். தட் இஸ் கால்ட் டூ-வே ANOVA. Both columns as well as rows, whether there is a significant difference between them, that's called homogeneity, and that's what we are checking there. In three-way ANOVA, columns, rows as well as treatments. காலத்தில் ஏதாவது significant difference இருக்கா, ரோஸில் ஏதாவது significant difference இருக்கா, ட்ரீட்மெண்ட்ஸில் ஏதாவது significant difference இருக்கா. So three-way we are analyzing. The one-way ANOVA is connected to CRD. That's what you have to understand. So one-way ANOVA is connected to CRD, completely randomized domain. That's what we talk about. Completely randomized domain. That's what one-way ANOVA. Two-way ANOVA is connected with RBD, randomized block domain. This is about two-way analysis. அதாவது காலம் வாய்ஸ் நம்ம டெஸ்ட் பண்ணுறோம், ரோ வாய்ஸும் டெஸ்ட் பண்ணுறோம். அப்படி பண்ணோம்னா அது எங்கே வருது அப்படின்னா randomized block domain. Third one we talk about three-way ANOVA. it is coming in LSD, Latin square design. LCLSD, Latin square design. So that's what we are discussing. So these are about the ANOVA. Now what are the assumptions in ANOVA? The observations are independent. Okay, whatever may we are observing. Okay, we are making a totality into blocks and plots, and we are applying and then we are observing that in that particular blocks how many elements are there. Then we are applying the treatment on them. So all those observations are independent of one another. Second one is the parent population is normal. The parent population, that is population from where the sample comes from, should be normal only. It's not from Poisson or hyperbolic like that. No, it is not. Only normal population only possible here in ANOVA. Third point, various treatment and environmental effects are additive in nature. They are additive. We must be able to add such assumptions are made in ANOVA. Now look at this. This is one-way ANOVA. Okay, one-way ANOVA, and this is connected to C or D. I already told you that. Am I correct? C or D. C or D. What is the meaning? Completely randomized. Design. C or D means completely randomized, design. So here is where we are using one-way ANOVA table. One-way ANOVA table is connected to completely randomized domain. So seriously you take this. Okay. Now the one-way ANOVA table already I was explaining inside the class, that consists of 1 2 3 4 5 columns and 4 rows. 5 columns and 4 rows, and that's what you have to understand. Since it is a one-way ANOVA, we have only between columns. This is not within columns. It's an error term. That's what we have to. In the class I have written as error here. So between the columns only, or between the row only, you will get SSC, that is sum of square column wise. Its degrees of freedom is C minus 1, and the mean sum of squares column wise, we can write it as this divided by this degrees of freedom. This divided by this SSC divided by C minus 1, where C is number of columns, is MSC. What is MSE? Here you will have some value. We have for the formula for that. And here is the total number of observations, here number of columns. So இதால divide பண்ணா நமக்கு என்ன ஒரு MSE you will get. Okay, right. இந்த ரெண்டுல எது பெருசுன்னு பார்க்கணும். Suppose MSE is greater, MSE is smaller, that you have to write the numerator, the greater number, and smaller number in the denominator, and that will give you the calculated value. Suppose this value is greater, this value is lesser, this value is greater, this value is lesser, then you have to write the greater value at the top and lesser value at the down. So that will give you FC value. Then calculated, these are the calculated value, and table value we can get from table. So these were some of the formulas to find TSS, SSC, SSCM. So that's what we take some problems now. These are the formulas. TSS equals summation x1 square plus summation x2 square minus t square by n. So what are the procedure? In examination they may ask you, write the one-way ANOVA working procedure or algorithm to find out one-way ANOVA. So one-way ANOVA, that's what the algorithm we have to find out here. ANOVA working procedure. So first step is about null hypothesis. Null hypothesis, we are assuming that there is no significant difference between the groups, between the columns or rows. That's what we say, groups we say here. So here we must take columns or row. Similarly here, between the groups there is a significant difference. So the opposite of this null hypothesis is this alternative hypothesis. Then we are finding out the calculation value of FC. Okay, and first step is we can find n, the total observations. The second one is t, the total number of observations. Third step is t squared by n, that is correction factor we say. This is correction factors. Okay, this is nothing. Don't take this as that. Correction factor. Correction factor we have to find. After calculating the total sum of squares by using this formula, then calculation of column sum of squares, that is sum of square column wise, we have to calculate this way. And then SSE is equal to TSS minus SSE. TSS you have to calculate from here, and SSE you have to calculate here. See the difference, that is SSE. And other things, MSE, this we discussed in the column. Now calculation of FT, that I will tell you, and that we have to calculate this way. F of c minus 1 comma n minus c, or f of n minus c comma c minus 1. Now last one is conclusion. If the calculated value is less than the table value, we accept H naught. If the calculated value is greater than table value, we reject H naught. Okay, so these were about C or D, completely randomized domain. So these questions, 2 more questions, they may ask any one of them. So in the next class I am going to take the one-way analysis coming in the completely randomized domain. Under that I am going to discuss about the problems. Okay, so that's all today. We'll meet in the next class.